Okay students, now we are going to see the third experiment in our syllabus. It is programmable logic controller. So PLC in short we can call it as. On the first experiment we have seen the pneumatic kit, that is manual operation. Then we have seen the electro pneumatic kit, in that it is semi-automatic, and today we are going to see the fully automatic operation using PLC. So this is the PLC we have in our laboratory, and this is the panel. You can see number of inputs and outputs you can take. So digital outputs, and this side you can see inputs. So red color indicates positive and black color indicates negative. So in this Fanuc, it is manufactured by Fanuc, and you can see here the number IC200UDD104, that is the PLC number. You have to remember this while doing your experiment. While interfacing, this number is required. So it is 1 to 24 volts DC. It is a DC device, and you have a switch. So this is the switch, on off. So you can on and off. And as you know, it is PLC, you can give the pulse inputs. So number of inputs, there are 9. So you can use any one. So this pulse input you can give. So this is the PLC kit. So third experiment you are going to execute on this. So this is the overall kit, and this is your pneumatic trainer, where you have solenoid valves, solenoid operated DCV. So you have this is one side solenoid, on the another side you have another solenoid. So once you energize this, this will activate this spool inside this DCV. So you have FRL unit, so that is FRL unit, and this is double acting cylinder, and we have 2 double acting cylinders here. So we can execute 2 operations, A plus, B minus, A minus, cascade, otherwise A plus, B plus, A minus, B minus. So that experiment we are going to see using ladder programming. So as you know, there are 2 types of programming in PLC. One is programming by ladder logic, and another one is programming by mnemonics. So in our laboratory we are not going to use any mnemonic programming. We are going to execute only PLC ladders. So here you can see 24 volts DC, and it is the positive connection and it is negative connection. Now this board receives the power that you have to connect to PLC. So positive to positive and negative to negative. So once you complete this, then only board will receive the power supply. So 24 volts DC and negative to negative, on both sides we have to give an input and output side. 24 volts DC is connected now. Now you can see the PLC receives power. This green light shows that it receives power. It is in on condition now.
Yeah, good morning students. So here we are going to see the VersaFlow. Is using a VersaFlow software, I go for simulation of PLC. So today I am going to do the A plus, B minus, A minus operation. So in that already we are using the 2 solenoid valve as well as 2 double acting cylinders. So here I go for connecting the PLC kit with the software. Okay. So with the help of the LAN connection, we are go for connecting the PLC software, VersaFlow, the name of the software, with our PLC kit. So I go for the PLC software, VersaFlow. So double click that, then go for file, new folder. So give name, click finish. So the home screen of the software will be displayed. So in that ribbon we are having the normally open coil contact. So as per our PLC ladder diagram requirement, so here I go for the ladder diagram type of PLC programming. So here you are having normally closed contact, then normally open coil, then these are things we are generally used for the all the repeated programs. Then in the case of vertical bit logic operations, here we are having that, or in the case of go for counter, we are having the up counter as a down counter. Then we go for another familiar one, we are having the off delay timer as well as the on delay timer. So OFD, off delay timer, ONDTR, that we call as a on delay timer. So these are normal retentive timers. So already we are having the theory about the retentive as well as the non-retentive type timers. Here again they mentioned the 100, tens and 1000. That indicates the time seconds we are giving. Suppose you are giving the 100 with the multiples of 100, we are giving us here seconds, time seconds. If you choose as a tens timer, you go for multiple of 10. So 20 means 2 seconds. Like that, in that way we are go for choosing the timers. Okay, so these are normal ribbon. Here we are having the vertical as well as a horizontal wire connection. Generally we call this a vertical or horizontal line. So this can be used for providing latch, nothing but AND type of OR type of logic circuits and all. So here go for drawing the ladder circuit. So this will be the positive connection, positive ladder. So two rung, two rail. So in between that we will go for drawing the n number of rungs. So I got first chosen as a normally open coil, then I go for normally closed, then output coil. So this is the first step of the A plus B plus B minus A minus circuit program. Next I go for latching, then I choose on the vertical line. So this will be latched, then this will be latched. For naming, so go for this arrow, click it and go for double click that particular coil. I go for 1I. So by default the software can be chosen as %1000I001. Okay. So next I can. So that's we call as a first input. So in that a PLC we are having the I1. So there we are having the numbers and yellow color indicates I1, I2, I3, I4, I5 like that. So that's a reason we are go for here given as a I1. So bottom we are having the green color indication of Q1, Q2, Q3, Q4. So this particular PLC we are able to given 8 inputs as well as we are able to take 6 outputs. So for the purpose in that software also here also naming a same name like I, Q, M. So M is nothing but internal memory. Okay, for the timer output we go for generally M. So in the case of output I go for 1 Q. So the software it can be converted as percentage of Q0001. Okay, so I go for latching 1 Q. So I go for next run. So next will be the timer. So go for timer. So in that on delay timer multiple of hundreds. So double click that and paste over here. So this particular rung they will produce one output. For that I can go for the normally open coil. So I go for naming it. So this will be the 1 Q. So the output of the first rung will be the input of the next rung. So those is a sequence of operation. So after that input 1 we are received. So after the time delay we go for the next output. For that we go for taken the output as a input in the case of next rung. Okay. So the output can be produced as internal memory. So 1 M. Okay. So same thing can be given here. So though this is one type of software, here this type of timer they need to reset that particular value. So in that they can go for giving some time values. So the R indicates that reset of that. So the PV indicates a preset value. So the time seconds we are given to that particular timer. So after the particular time seconds, is going to be reset once again to the 0. For that, this timer needs some output signal. So whether this timer is able to produce the output or not. So that can be indicated here. So that's the reason I am indicating the output same as taken as input for the OR. Okay. So once I am able to get the output M1, so that can be indicated to the previous output. So that's the reason I go for normally closed coil. So to break the particular first rung. So that's the reason I go for normally closed coil in the case of rung 1. That means, so the next time will be completed. The first timing will be completed after the input 1 can be produced. After the time second delay, we are able to go for another output. So I go for breaking the circuit in the first rung. So that's the reason I go for the normally closed loop in the case of first rung. So I go for draw the next then go for latching, draw the vertical line. So here I name it as 1m. So here I just output of 2q. So those are q1 and q2. So these two are the main output of our PLC kit. So for that definitely we need the latching. Okay, so again I can go for the one normal post coil. Next I go for another timer. So though as of now we are getting two outputs. One is here q1, other will be the q2. So after q2, so that means a plus, b plus. So b minus we need some time delay second. So for that I go for again one timer. 100 multiple of hundreds placed over here. Then this will produce one output. So this will be the 2m. Okay. So for that I go for resetting that. So this will be 2q and this will be 2m. Now this normally closed coil will be 2m. I breaking the output number 2 because the output 3 can be produced after the time second. So M2 will get energized. So same time I able to get the output of Q3 after the timer. Next I go for drawing the A minus. So here I go for Q3. So this is the 2m 3q, third output. That means A plus B minus operation 3q. So next I go for another timer. Go for timer, on delay 100, paste over here. Then this will produce one output as a memory coil. So here I name it as 3q. This will produce output as 3m. So here I am go for resetting that time second as 3m. So after that 3m, you are able to get the output of Q4. So that operation we call as A minus. So once the 3m will become, so next operation, so that I go for breaking the previous circuit, that's why I go for the normally closed one. So here I name it as 3m. Next I go for the final output. So 3m as input for this run, the output produced will be 4q. So A minus operation. So I go for latching that Q4. So after A minus, you go for another continuous reciprocation. So A plus B minus A minus. So one time only we are go for giving the input. After that we go for the continuous reciprocation. Further we need another one timer. So far we are able to get 4 outputs. So Q1, after some time seconds we are able to get the Q2. After some time second we are able to get the Q3. Then after some second we are able to get the Q4. Next to 1 second we will keep on to the 1 second Q1, Q2, Q3. Further in between that we need some time delay. Further I go for another timer. Okay. So go for timer. ONDTR 100. First I draw that 2 coil. Then I go for ONTR 100. Then this will produce an output. So this named as Q4Q. Output produces 4m. Here I reset in that, so I go for 4m. So this also again as a break the previous run. I given as normally closed coil as 4m. So as of now I completed that entire circuit. I didn't give the time seconds. Here I go for latching on extra. So this will be the output of the final timer 4m. That means after the A minus, so we need to start the next operation. Again A plus B minus A minus. For that I go for the final timer output. 4m can be latched once again to the run 1. Okay, to start the another operations. Okay, so this is a ladder diagram for A plus B minus and A minus. Okay, so here I go for using the 3 timers. So 4 timers. So timer 1 can be used to in between the A plus and B plus. So timer 2 can be used between the B plus and B minus. Timer 3 can be used between B minus and A minus. Timer 4 can be used in between A minus, once again the another operation of A plus. So that's the reason you go for the 4 timer. If you don't want the continuous operation, I go for stopping a single operation like A plus, B minus, A minus. I go for, with the help of 3 timers, I can able to complete the circuit. If you need that continuous operation, that means once again start A plus, B minus, A minus. That means and further you go for continuous reciprocation. In that case, we need the 4 timers. So next I go for assigning the values to the timers. So just double click that. So they asking the address as well as the length. So though it's one of the type of microprocessor type like that. So I go for multiples of 5, or in the case of multiples of 6, we are assigning the registers. How in the case of microprocessor, the registers can be used as a memory. Here also we are assigning the registers to time calculation. That means here particular register can be alerted for the time running as well as presetting the time value. So here I go for 5R, enter 5R, click OK. So it can be considered as a percentage of R005, like that can be coming. Okay. So next in the above the PV. So just click nearer to the PV. So in that give 10R. Okay. So for like this in the case of all timers. Already given the 5R as well as a 10R. Next I go for 15R. So multiples of 5. So above PV I get to 20R. So I go for timer 3, 25R. Here I given 30R. Next I go for timer 4, 35R. So this will be 40R. So I assigning the register value. So I didn't giving the time seconds, delay seconds. Only assigning the register value to the timers. Okay, like a 5 or 10 hour. So that's in the inside that 5 hour that can be used for running the time counts. This register can be used to preset that value. That means the value which you are going to given. So that can be stored. For this we need the register in the case of PB. Okay. So in that case we are assigning the registers to the all the 4 timers. So next I go for, so far I connected the PLC as well as the software. I didn't configure the particular PLC number. I go for configuring the PLC. So before that I check it whether it can be connected. So go for the configure, open configure window. So in that just go here, open hardware configuration, double click. So here they are having the PLC display. So what we are having in here, that kit. So in that they are saying giving some numbers. So like 104. So I go for right click that, go for replace that particular model. So go for replace model and click it, search it where that IC 200 UDO 104. So this will be there our PLC. So click it, give OK. That means a particular PLC can be connected with the software. Click OK. They asking you want to replace the CPU? Yes. Then settings also you want to replace? Yes. So this window can be enabled. Here you go for password as a disabled one. Just right click, double click and give us a disable. So this password enable and disable can be in industry point of view, we are having the supervisor type of control. So that particular supervisor having control over to editing that particular program. So for that they having that this type of password enable, disable and all. Click close. So just check it whether we are able to get that particular PLC number. Please close. Then save that. Yes. And close this window also. So as of now we are configuring the particular PLC. Next I go for connect the PLC. Go for connect. So choose the default connection, then computer 1. Go for connect. So it can be connected. Okay, once it get connected, so we are able to get the enable of disconnect. So now as of now the connect will be disabled. Okay. Next I go for storing this particular program. So this ladder diagram to the Versa Pro software. Already we are drawn with the help of Versa Pro. We are going to feed that program to the our PLC model. So that I go for PLC. So clear that. Before going to feed, I want to clear previous program. So that I go for all the thing, IO input, all the things I go for clear. Select all. Click OK. Click yes. If this window came, so that indicates that you are connected with that particular PLC. Click OK. Clear will be completed. Click OK. So now you go for load that program. So I go for store the hardware configuration and store the logic to the PLC. First two can be checked and click OK. So this window, pop-up window can become store to PLC can be completed. So once this came, like that, we have the program you have drawn using the Versa Pro software, that can be correct. If there is anything miss, any particular rung or anything, any coil you are missed the name of the coil, so you won't be get stored can be completed. So that's another error showing. In bottom also we are able to get that indication of all things can be storing correctly. Okay. So click OK. Now we are able to see that all the normally closed coil will get the red color indication. So that means it's ready for simulation. Next, in timer and above PV, we are able to get 00. So this already told that this register we are assigning for running the time counts. So this PV can be used for storing what time delay we are going to give. So go for click the right click 0 and go for right. So in that we are going to navigate the counts. So 200. So I go for 2-second delay between A plus and B plus. I am giving as a 2-second delay. So between B plus and B minus I am giving 3-second as a delay. Right click right. Go for 300. Let's go for timer 3. So in that above PV the 0 will indicate. Right click, go for right, and then I go for 200. 2 seconds of delay between B minus A minus. Next another cycle of operation, that means continuous operation. I go for right click and giving 4 seconds as a time delay. So I giving the assigning the time values to the 4 timers. So first timer I given 200 as a time second, that means 2 seconds as a time delay. Then second timer 3 seconds as a time delay. Then third timer I given again 2 seconds as a time delay. Then for another continuous operation like a fourth timer I am giving 4 seconds as a time delay. So why I mentioned 200, 300, 400. So though we are choosing on delay 100, that means multiples of 100 only are going to given the time delay. Next I go for the simulation. So here we are having the start stop button. If I start that, we go for start simulating the PLC. So go for run. So in that run, as of now same as it is the software will behave. If I switch on that input switch in the PLC, I am able to get the simulation of software here. So just I go for switch on it and off. So immediately I am able to get the output. So here I go for start stop button. So in that I start running the PLC. So now I go for the switch on the PLC kit. So parallelly giving only one time as given as input. So next I am able to get the timer 2, timer 3 and timer 4. Again Q1. Okay. So 4 seconds after Q1, 2 seconds after Q2, 3 seconds after Q3, then 2 seconds after Q4, then 4 seconds after again Q1. So this is a continuous operation. So A plus, B minus and A minus. So in carefully we are going to see in the software also. So here I having the running time. Inside we are running based upon that we are able to get the output of Q1, Q2, Q3. Okay. First we are able to get the Q1. So after that we are able to get the Q2. Next we go for Q3. Next Q4. So 2 seconds after 4 seconds Q4. Again 4 seconds we are able to get the Q1. So likewise we are able to get the output Q1, Q2, Q3, Q4. So parallelly connected with the solenoid coil. So as of now we are able to get the 4 outputs Q1, Q2, Q3, Q4. I told that PLC can able to produce only the 24-volt DC signals. So that signal can be utilized by means of solenoid valve. So through that we are go for actuating the double acting cylinder. So we are able to get the particular sequence of operation. So now you go for connecting the solenoid with the PLC kit. So though it is a rod end, so this can be. So now you go for giving the connection to the 2 double acting cylinder to make the sequence of operation. So here I can connect this is to the rod end. So this will be the A plus. So this can be given to the Q1. Then so the red color indication the positive, then black color indication negative. So this will be the A minus. So I can given to the Q4. So next, this connection can be given to the rod end. So this can be a plus, B plus. Then this will be the B minus given to the Q3. So as of now I given the positive connection of 2 5/2 solenoid operated valve. So B plus, B minus, A plus, A minus. Okay. So now you go for giving the connection of negative terminal. So all the negative can be grounded and placed over the common negative. So interconnect all the negative connections and commonly grounded to the one place. So once I get the connection, I am able to get the triggering sound on both the solenoids. So A plus, B plus and A minus option. I go for enable the knob for actuation. So extension of cylinder 1, then B plus cylinder 2, B minus, A minus. Again continuous reciprocation. So again I go for A plus, B plus, B minus, A minus. Repeat that. So I get the simulation of A plus, B plus, B minus, A minus. So this is a circuit connection for 2 WRT cylinder extension retraction. Okay. Thank you. Now if you want to change any connections, like if you want to change any order, if you want this cylinder want to first extension then go for next cylinder, if you want anything parallel you can go for changing that. So as of now I give the connection as A plus, B plus, B minus, A minus. If you want A plus, B plus, A minus and B minus, so simply change this output alone. Don't go for further any changes in the circuit diagram, just I can change simulation. So A plus, B plus, A minus, B minus. So only thing I can change the power or the triggering signal given to the solenoid. So that alone more than enough to change any circuit of operations. So that's the advantage of PLC. So PLC can able to produce only the output in a case of electrical signal. So that electrical signal can be given to the solenoid to actuate the WRT cylinder. Okay.